Hello students, so here I am Mrs. Ahuja with chapter number 11, Work and Energy. In our daily life we do different types of work. All these work can be physical or mental work like cooking, washing, chopping, reading, writing, etc. All these work require energy. But can you calculate that work? So in physics we will study how we can calculate work. Work is done when applied force cause displacement in the object. So two things are necessary, two things are essential for work, that is applied force and second is displacement. So we can say that work is dependent on force. The large force you will apply on the object, the large amount of work will be done. In the same way, if there is large amount of displacement, so definitely the work will be in large amount. Clear? So by combining these two equations as work proportional to force and work proportional to displacement, here W is work, F is force and S is displacement. So by combining these two equations, W equals to F into S, or we can say work equals to force into displacement. So in other way we can say that work is equal to the product of force and displacement. Now come to the unit of work. Like the unit for force, that is Newton, and the unit of that displacement, this is meter. So here we can say the unit for work, that is Newton meter, or we can say joule. Joule is the unit for that work. Students, as in the horizontal surface, here you can see that this is a horizontal plane surface, and suppose there is a box. Fine? Here it is a box. So if I have applied force on this, so here you can see that the object will move in this forward direction. It will displace in this forward direction. Fine. So now we can say that force as well as the direction or the displacement, both the directions are same. It is in forward direction. Force, applied force as well as displacement, they both are in the forward direction. They both are in the same direction. So we will use this formula for calculating work. And the unit for work is joule, or we can say Newton meter. Here you can see that as applied force and displacement, they both are in same direction. They are in forward direction, they both are in same direction. But what happened when they both are not in same direction? So this we will study now. When direction of applied force and displacement is not same. So now here we will go. Like this is your bag, or we can say here is a trolley. And when you have applied force here, you are holding this from this place, and when you are applied force, so here we can say it is in this direction. You have applied force in this direction. But what do you think so? This trolley or this bag will move also in that direction? So your answer would be no, because it will move in this direction. The direction of the displacement would be like this. Fine. So in this condition we can say that applied force and displacement, there is an angle in between these two things. Means in applied force and in displacement there is an angle. So they both are not in same direction. So now how we can calculate work in this condition when there is an angle between force and displacement? So suppose if it is theta, the angle between this, it is theta, suppose this is theta. So how we can calculate work now? So now we will use one formula for calculating work, that is, as I told you before that W equals to Fs, where F is force and S is displacement. So here W equals to Fs cos theta. When there is an angle between force and displacement, in that condition we can calculate work by this formula. It means W equals to F into S into cos theta. Now you can ask why I have taken cos here, because as we know that cos equals to base upon hypotenuse. Fine. So that's why I have taken cos here. And for your convenience, I have written this table for you. Thank you so much for watching this video. Thank you.